You're watching the first of a few exam review videos to help you through the answer key. So we'll go through probably problems 1 through 10 on this video. So in the first problem, we're just trying to prove if the triangles are congruent. So remember, you can always mark a shared side. And then if we look at the markings, we have angle, side, angle for problem 1. In problem number 2, we have an isosceles triangle. So the first thing we know are that base angles are congruent. Then we can find out what this upper angle is. So if we add 46 and 46 and subtract from 180, we get 88. That's the entire angle. But these two arcs indicate they're congruent, so angle Y would be half of that, so that would be 44 degrees. And then to find X, you can add 44 and 46, that gives you 90 degrees, so angle X would be 90 degrees. In problem 3, we have an isosceles triangle, and we have an exterior angle here. Well, in an isosceles triangle, the base angles are congruent. So this angle is the same as 5x minus 30. So if we put 5x minus 30 in here, that would mean these two angles are a linear pair, therefore they're supplementary. So you can add 5x plus 5x minus 30 equals 180. 10x minus 30 equals 180. 10x is 210. X is 21. For number 4, if RQ is a perpendicular bisector of PS, draw a picture. And angle PR is congruent to angle PSR. So if we say angle SPR is congruent to PSR, SPR is here, so we can put in some dotted lines here. So these two angles are congruent. By the perpendicular bisector theorem, these two sides are congruent. We have a shared side there, and perpendicular means we have right angle. So we can conclude that these triangles are congruent by hypotenuse leg. For number 5, if we want to try to prove these congruent by HL, we have the right angle, we have the hypotenuse, we need a leg. So you could choose either one of the legs, so I'll just choose AC, and that would need to be congruent to CE. And that would give me enough information for a hypotenuse leg. In number 6, congruent corresponding parts, you start by naming angles. So angle C would be congruent to angle E. Angle B would be congruent to angle D. Angle CDB would be congruent to EFD. And then you name the corresponding side. Side BC would go with side DE, and so on. So you're listing the corresponding parts, go off of the congruent statement. In problem number 7, we go quadrilateral L, K, J, I, so order matters. So L, K, J, I. So we need to go N, K, J, M. N, K, J, M. So corresponding parts match up. For problem number 8, we have triangle RST, draw a picture, and triangle UVW. Angle R is congruent to angle U, ST is congruent to VW, and angle S is congruent to angle V. So if I want to do angle side angle, I would need to move this side to SR or this side to VU. So right now this is angle side. So you need to know that RS is congruent to VU. Okay, in problem 9, we have a very large amount of things going on in here, but very simply we want to figure out that BF would be congruent to another piece. So if we look at these two triangles here, this one and this one, I'm ignoring everything else. So these two triangles have a pair of congruent angles, and they have a shared side. So these two triangles would be congruent by side angle side, and then FE would be congruent to BF, and that's our CPCTC. So these two triangles are congruent, therefore the remaining parts are congruent. Okay, for number 10, we want to complete the missing reasons. So these are right angles. That's the definition of perpendicular, because perpendicular segments create right angles. SH is congruent to ST. That was given. So you can mark your diagram as well. Reflexive property, SD is congruent to SD. And then by hypotenuse leg, the triangles are congruent.